We've done that. So we've done that. We've gone live. We are live. We are live. We are live. We are live. We've still got a couple of minutes to go. Yeah, we've still got a couple of minutes to go before we start properly. But I thought we would start the live stream a little bit early because there are people in the waiting room, and I thought it would be interesting to have them in the chat. There is chat available, public chat in the YouTube channel. So if you want to talk to people there, you can. If anyone's got any quick questions while we're waiting to get started, then far away in the chat. Me and David just going to sit here and wait.
I'll just say hi to everybody that's joined early. You're the keen ones if you were waiting in the room there to get in. So that's really good. Nice to see that you're keen.
When I said hi at about 20 minutes to 8, there were 4 people in the chat room already waiting.
Wow.
I know. And I'm particularly keen on this tonight's talk because I am a Virgo. And I'm a typical Virgo.
You never are.
I don't even know what that means, actually, to be honest. I wouldn't know what a typical Virgo was. If it's a stubborn pain in the bum who always thinks they're right, then yes, that's a typical Virgo. What's the rock on the book? I should get an actual picture of the rock. This rock on this book. This is a meteorite. This is a 2 kilogram iron nickel meteorite called the Campo de Cielo. I hope I've pronounced that right. And this is landed in Argentina about 5,000 years ago. And it was found, I think, if I remember correctly, about 1,500 years ago or 500. I can never remember. Do you know what, Dave? I was just thinking it's been a year almost since we've done these kinds of talks in the observatory properly anyway. I can't remember half the stuff that I'm meant to know. When we reopen again in May, it's going to be anyone coming along to the events is going to have a really interesting time as we kind of like...
Oh, it'll all come flooding back very quickly, I'm sure. But yeah, it's true. You use it or lose it. So it's amazing how quickly some of it escapes your brain, but it's amazing how quickly it comes back as well when you have to do it. Like
riding a bike. Yep, so that's a magnet I've popped on there just so you can see that it is lovely and iron and magnetic. And yeah, you can, these are actually the cheapest and one of the most stable iron meteorites to own. Campo. They're called Campo. C-A-M-P-O. I nearly spelled that phonetically because I've got a 5-year-old. My daughter's 5, and everything, all the spelling and reading we're doing in a minute is like. So hello to Stephen King. We like your books. Thank you for joining. James Clark. Hi, Rory. Doug Wells. Oh, it's Doug from the Chipping Norton Amateur Astronomy Group in Oxfordshire. Good to see you, Doug. We will give it a couple more minutes, I think. But what I'm going to do is share a screen because we are doing this as part of the International Dark Sky Association Dark Sky Week. Don't know if you knew that, Dave.
Yes, I had heard of it. So it's
yeah. So, and there's lots of events on virtually and presumably in real life for those people who have countries that are managing lockdown better than ours. But if you want to check out the website for the International Dark Sky Association and see what other events are on and places and people and things like that, then that's where you go. I recently renewed my membership actually for the International Dark Sky Association. It's only $35, and that's a bargain. Are you a member yet, Dave?
Sadly, no. To my shame and embarrassment.
$35. Well, I'll put the link in the chat for everybody else.
Great idea. Yeah, good.
I'll promote that. I mean, basically, what we're hoping to do is make people appreciate that light pollution is a horrific form of pollution. You know, I mean, you're about to talk tonight about the Virgo cluster of galaxies, which is this, you know, beautiful group of really massive objects, billions upon billions of stars that are best viewed, you know, in dark sky sites or in reasonably kind of rural, urban kind of sites. But wouldn't it be great if no matter where you were, lighting was done so well that actually you could go out at your house at 10:30, 11 o'clock at night. All the street lights would be pointing down. There'd be the right color, shade. They'd have been dimmed already because, you know, who's out at 10:30 apart from people going home. You know, you could see the Milky Way in your back garden in Gateshead or Manchester or whatever. Imagine that, Dave. Wouldn't that be good?
Wouldn't that be fantastic? And I think that's got to be the aim of the Dark Skies campaign. It's because there's no reason why you couldn't achieve that if everybody was sensible with the lighting and shielded properly.
Yeah, I think you're right. I think the problem is that people don't really want to do stuff like that, though. Especially not businesses. People, astronomers like us, do, but businesses don't really, do they? So I think we'll end up seeing quite a bit of legislation over the coming years, especially as people appreciate more and more that light pollution kind of affects habitats for animals and humans and all that kind of stuff. So there we go. I think we'll see, won't we? And human health as well. You know, if all this research is true, that hypertension, heart disease, cancers, quite a strong link to, for some reason, colon cancer with light pollution. If there was a big meta study done 7 years ago. Hi from Wigan. Hi from Sandy Astronomical Society and Blackpool and so on. Yeah. Oh, you're welcome, Doug. Anyway, Dave, listen, I have, I believe, set up screen sharing for you. So you can get whatever windows and PowerPoints and things you need to get ready in the Zoom and do all your sharing and whatnot. And I think we're probably ready to begin. Yeah.
Great. Well, okay. Well, I'll share the screen then. Thanks, Roy.
Yeah. And I'll just point out to people that although this is scheduled to run from 8 o'clock to 9:30, we're taking it quite casually. And obviously, if Dave wants to carry on up until 9:30, if people are asking questions, that'd be great. If there's a few of us still here after 9:30 and we still want to keep talking, we will. But if we run out of steam a bit earlier, we'll stop.
Well, if I'm still going by 9:30, kick me out, please. I've gone on far too long if I'm still going at 9:30.
And what we will try and arrange halfway through is when we get to about 9:15, 9 o'clock, and people start to get a bit sleepy, we'll arrange for Dave's dog Odin to bark horrifically and loudly and wake everybody up.
That's a very good idea. That does have a habit of waking people up. So yeah, is lying there in the corner of the room. So yeah, is lying waiting and ready for that.
Well, thank you, Dave. Dave Newton, over to you.
Okay, thank you. Let's just get this up on the screen. Now, with a bit of luck, you should see my presentation coming up with Visiting Virgo. Is that visible to everyone?
I can see it, and it looks like, and it's on the live stream. So that's perfect. I'm going to mute my microphone now, Dave. Okay.
Super. Thanks, Roy. Okay, well, thanks for tuning in tonight and listen to me talk about Virgo. Not just Virgo. I'll be talking a little bit about Leo and some of the surrounding sky, because the Virgo Supercluster actually stretches across quite a bit of the sky. A very interesting target. This is the ideal time of year to view it, and I'll explain why in a couple of minutes. But first of all, we'll have a picture of myself there with my solar filtered binoculars doing a bit of sun spotting. For the people that know me, they know that I've been an astronomer for a very long time. It's over 50 years now as an amateur astronomer. I like a bit of everything. During the summer, I like to do a bit of sunspot watching. Sun, fascinating object, very, very close to us in space. Even closer than that is the moon, our nearest natural neighbor there in space. Fascinating object. I love to observe the moon, particularly during the winter time when the full moon is very, very high in the sky. Great object, never fails to amaze me, the amount of detail that you can see and how those details change from night to night as the shadow moves across the surface of the moon. But if there's one thing that fascinates me observationally more than anything else, it's galaxies. And here we have the biggest and brightest and most famous one of all in the sky, the Andromeda Galaxy. About 2 million light years away, visible with the naked eye. And if you think about it, that's quite remarkable, really. The distance to this is over 2 million light years, so the light is taking millions of years to reach us, and you can see this with the naked eye from a dark site. And that tells you something about it. It must be very, very large. And I think this is one of the things that does fascinate me about galaxies. Everything about them is absolutely astronomical, literally. The distances to them, millions of light years away. The numbers of stars in them, we're talking about billions of stars in every galaxy. The size of them, it takes light about 100,000 years or more to cross across a spiral galaxy. So all of these numbers are incredibly vast. I think that's part of the attraction for me. It's the fact that you can actually see these things that are so far away with a backyard telescope. Now, until a few years ago, these were out of reach for me. Galaxies were one of the things that I could never observe from my light-polluted back garden. There was too much light pollution. I didn't have a telescope that was big enough. But then about 10 years ago, I purchased one of these beasts. This is a Skywatcher, a 12-inch Dobsonian telescope. And all of a sudden, I had the aperture there. I had this light bucket that was capable of seeing galaxies. Happy days. All of a sudden, a whole new branch of observational astronomy was open to me. So you need something that's big enough to see galaxies. And the other thing that I found an absolute real bonus is one of these, a light pollution filter. I've actually got a UHC filter, which is an ultra high contrast filter, but it does the same job. Well, certainly the one that I've got does. It blocks out a lot of that light pollution, but it lets through the light from the stars. So between having the right filter and a reasonably big telescope, all of a sudden I can now see galaxies, and I can happily work my way through the Messier catalogue of these faint fuzzies. Now, springtime is the ideal time to sort of track down these objects in the Virgo cluster. The reason being, in the evening sky at this time of year, we're actually looking right out of the top of this thing here. This is the Milky Way galaxy. This is a mosaic of the night sky, and it's been laid out sort of flat with a Milky Way spread across the middle. So in effect, this is what the Milky Way would look like side on if you were outside of our galaxy. Now, if you are looking sort of through that galaxy, through the disk, then all you can see is thousands and thousands of stars. And that's the Milky Way that we see in the night sky. But at this time of year in the evening sky, when we look up, we're actually looking out of the top of this disk, where it is thinnest. And that lets us look into really deep space, where we can see all of these other galaxies. So happy days for me. This is great. Springtime is one of my favorite times to observe because we're looking out of our own galaxy into deep space. And the same kind of thing is true 6 months from now. When you get to the autumn sky, there aren't a lot of bright stars in the autumn sky. And again, that's because we're looking out of the bottom of our galaxy's disk in that case. Again, we're looking out into really deep space, so we can see lots of galaxies there. In terms of what we're actually looking across, the autumn sky is kind of to the upper left on this diagram. You can see Milky Way sort of written in small letters at the center of this slide. So the autumn sky, we're looking out towards Pegasus, Perseus, and that's over on the left-hand side. The spring sky, we're looking over to the right, and you can see quite close to us on this diagram, the Virgo cluster. So we are really very close to the Virgo cluster. We are closer to the Virgo cluster of galaxies than any other, which is why it's such an important target for scientists. In astrophysics sense, there's an awful lot we can learn from this because it is far and away the nearest cluster and supercluster of galaxies. So our viewpoint, I think, is a little bit like this observatory here. This is the Griffith Observatory in Los Angeles. It's in Hollywood, and it is very, very close to the edge of Los Angeles city. So kind of our vantage point here, sort of on a spring night, as we look towards Virgo. Here we are, the Milky Way is sat just sort of on the edge of this Virgo supercluster. And as we look towards the constellation of Virgo, we are looking right into the heart of this city, this busy city full of thousands of galaxies. Wider again, this little diagram here, this animation shows you what the structure of the universe is like on those sort of really massive scales. The clusters of galaxies and the superclusters that we can track down, they seem to make up these strings and walls of galaxies with enormous voids in between. So in the springtime, we're right on the edge of these sort of walls of galaxies. But in the autumn sky, we're looking out across one of these voids in totally the other direction. Anyway, from deep space to my back garden, this was a photograph I took on my mobile phone last year, and this shows quite badly. It's not a great picture really, but it does show quite clearly the stars of Leo. And I'm going to start with Leo because it's a very bright and obvious constellation. It's a little bit more recognizable than Virgo itself, and it's next door to Virgo. Virgo is just to the left-hand side of Leo on this picture, so it's a really good place to start. What I'll do is we'll draw some lines on there, we'll connect the dots so you can see the shape of Leo. You need a bit of an imagination for this, but I think actually it's not far off. If you imagine a lion lying down, there's its body sort of in the middle, stretching out to the left-hand side, and the head of the lion is that sort of sickle shape on the right-hand side. It's called the sickle of Leo. That represents the lion's head. And it's like a backwards question mark. But our first port of call when we're looking for galaxies is going to be just underneath the lion there. So if we drop that circle there onto the slide, just inside there is a very famous and quite obvious little cluster of galaxies. So it's a good place to start. If we go from a photograph to a star map, this is what we are looking for. Again, the lines are drawn on that so you can see the shape of the lion. And they're labeled on the map. We've got M65 and M66, and these are what we call Messier objects. These are the two galaxies, Messier 65 and 66, that appear in Charles Messier's list of fuzzy non-stellar objects, the faint fuzzy things that he didn't want to confuse with comets. So there's 110 of these things in the catalogue, and quite a good number of them are actually galaxies. Now, this is that little cluster, M65 and M66 on the right. Big telescope, dark sky, these are completely obvious. What's not quite as obvious is the other galaxy, the slightly larger one, which is on the left-hand side, which has this NGC catalogue number. It's more often called the Hamburger Galaxy, because we're seeing it side on. It has that streak of dust through it. So yeah, somebody looked and thought, yeah, it's a bit like hamburger, isn't it? Now, I think this is a good way to test the sky conditions. If you can see the Hamburger Galaxy, that's great. The sky is clear enough and dark enough for you to be tracking down galaxies. If you can't see the Hamburger Galaxy, but you can see M65 and 66, I think you're going to struggle with some of these other Messier objects. So if you start here, this is a really good test of the sky conditions, I think. Now, this is obviously a long exposure photograph or a CCD sort of image of the sky, so it shows us galaxies in lovely detail. You're not going to see that through your amateur telescope with just an eyepiece. You don't see that level of detail. And this is a little bit closer to what you will observe of M65 and 66. That's vaguely what they look like through my 12-inch on an average sort of dark night here with a 26mm Plossl in the eyepiece. So you can get both of those galaxies in the field of view, and that's a decent approximation of what they actually look like. And here's a top tip for you. This picture here actually is taken from this book. Here's my copy. The Cambridge Deep Sky Album. It's rather an old book now. These are old wet film photographs in it. Canadian astronomer called Jack Newton did a lot of photography, and they produced this book. Everything is to the same scale. same exposures and all of the objects, so you can do a direct comparison of them. And the wonderful thing is, I think these photographs that is taken do give that good approximation to what it's like through the eyepiece. So if you see a copy of this book somewhere, it's worth getting it. It really is. Or if you know, look it up on Amazon, there might be some second-hand copies you can get. So prepare yourself for a night of observing. That's a good book to have handy. Anyway, back to Leo and these bright galaxies there, which are our starting point. There's actually two groups under Leo. We've got M65 and 66, and then a little bit further to the right, under the body of the line, we have Messier 105, 95 and 96, and another triplet there. These are actually part of the same cluster. It's called the Leo 1 group. And just like our cluster of galaxies here with the Milky Way and Andromeda, these are actually a part of the Virgo Supercluster. So there's no trick here by starting with Leo. You are actually observing part of that Virgo Supercluster. So we've got M105, 95 and 96 on the right, M65 and 66 on the left, and there's this NGC galaxy in the middle which sort of connects the two. But this is one of those strings that make up part of the extended supercluster of galaxies. Looking a little bit wider, there are a lot of other galaxy groups that are much fainter, also in this region. And these are called the Leo 2 group of galaxies. Now, these are roughly speaking about 10 times further away. And I will come back to this later on in the talk, just very, very briefly. But they're much further away, a lot fainter, which is why none of them appear in the Messier catalogue. But dark sky, big scope, yeah, you can track some of these down if you really want to. So anyway, let's move a little bit further left now, left of Leo into the bowl of Virgo itself, because this is where the center of the supercluster is, and the center of the actual Virgo cluster is. And boy, if you like galaxies, you're spoiled for choice here. There are hundreds that you can see with a big backyard telescope. A professional telescope, you can capture thousands of galaxies. There are about 1,300 at least galaxies in the Virgo cluster. The extended supercluster, you're talking maybe 100,000 galaxies. So this is a very, very big object. And remember, each galaxy contains hundreds of billions of stars. So they're really, really quite vast objects, these superclusters. This is a nice picture here, I think. This is taken off Wikipedia. What somebody's done is, it's a photograph stitched together of the Virgo cluster. And they've taken out all of the stars and all of the bits between here and there. So it's just leaving the galaxies. What a remarkable picture that is. This is the center of the Virgo cluster. Wow, look at all of those objects there. It's really quite amazing. And a good chunk of this you can see for yourself from your back garden if you've got, you know, a reasonable size scope and it's dark enough to actually start seeing galaxies. Ooh, trying to track them down on a star map though gets really confusing because there are so many of them. When you look at this and you look at the labels, it's just there's so many little lines and designations. It's a nightmare. How are you ever going to make sense of this with your telescope? Unless you've got a computerized telescope and you can just program it to look at one after the other. For me, part of the challenge is to actually do it by star hopping to them, using an atlas, tracking them down yourself. I love doing that. And to do that, you have to tackle it in a particular way, I think, and be quite methodical about it, because it is so easy to get lost in something like the Virgo cluster. It's a bit like this, yeah? You look into a bowl of Rice Krispies, there's just thousands of galaxies there. Where do you start? How do you identify them? Well, fortunately, there are ways. What we're going to do is actually use some of the bright stars around here as pointers. And by looking at little strips of sky, we can actually track down these galaxies one by one. And that's how we're going to tackle this. So here's a star map. I've got a series of charts that are great because they're printable ones and I can draw lines all over them. And I found this works well because the brighter Virgo galaxies, all of the ones in the Messier catalogue, actually fall reasonably well onto these lines that run between the tail of Leo, so Beta Leonis, Denebola up there at the top right, and the stars in the bowl of Virgo. So if you draw lines between Beta Leonis there and these other stars, what you find is you've now got some straight lines that you can aim your telescope along, and you can start to find these galaxies. So we're going to start at the bottom of the bowl of Virgo, and we're going to track down M61. So this is the strip of sky we're going to look at, and it's just over a third of the way up from Gamma Virginis there at the bottom. So a third of the way up that straight line. If you sort of drift your telescope up that line, you will come to M61, which is this rather lovely face-on spiral galaxy. Reasonably bright, magnitude 10.1, so it's a start with. Very, very nice galaxy. And with something like the Hubble Space Telescope, the amount of detail that you can see in this is absolutely remarkable. They do make very good targets in the Virgo cluster because they are quite close. The center of the Virgo cluster is about 55 million light years away from us. But if you think, we are on the edge of that. So between here and the center of the Virgo cluster, there are lots of galaxies. So some are a bit closer, some are a bit further away. You know, it stretches for another 55 million years on the far side of the galaxy cluster. So M61, beautiful spiral, great place to start. If you can find that, great. Let's move on. Next one up. Again, this next strip, which goes from Delta Virginis there on that side up to the tail of the Lion. Another bright galaxy there, Messier 49. Same story. It's about a third of the way along that line. A little bit over a third of the way, actually. So again, drift your telescope along that line. Just move it in a straight line, look through the eyepiece, and just over a third of the way, you will encounter Messier 49. Very different object, this one. No spiral shape to it. It's just a big, round, fuzzy blob. This is what we call an elliptical galaxy. We think that they might have formed by mergers between spirals. Not completely convinced by their argument, some people. But what you find is that the centers of galaxy clusters usually have a fair number of these large elliptical galaxies that really don't show any detail. Doesn't seem to be formation going on in these. That seems to be limited really to the spiral galaxies. So, okay, we've looked at two galaxies so far and two very, very different ones. One of the good things about the Virgo cluster is you've got a good example of pretty much every type of galaxy if you look for it, all in this one little sky. So having warmed up with those two galaxies, we can now move on to the main strip. So the top of the bowl there, so Epsilon Virginis across to the tail of the Lion, drawn that box there. This is the prime location, and this is where we are really looking into the center of the Virgo cluster. We're going to start from the left-hand side and then work our way to the right. So that's sort of from east to west. So again, in the night sky, get your telescope there, start with Epsilon Virginis and just drift towards the tail of the Lion. And the first galaxy you'll come to, look at this sort of crowded field of galaxies. The first one you come to is M60. So this is the direction we're going in. M60, M59, and M58 are our first three targets. So if you drift in your telescope along, this is the first one you will get. This is M60. Again, it's a big fuzzy blob, big elliptical galaxy. But right next to it, we've got this NGC galaxy, a little bit fainter in magnitude, 11 point something. So you might not be able to see that depending on the size of your telescope and the sky conditions. But yeah, if it's a big scope and a good night, hopefully you'll be able to see not one galaxy here, but you'll see two. You'll see that companion there to M60. So two for the price of one there. A really nice contrasting pair, an elliptical and a spiral galaxy. The next one was M59, magnitude 10.6. So again, not a lot of detail in this. It's a big, faint fuzzy. And a bit further across, there's M58. Now you can see these are almost in a straight line. lines. So once you've found the first two, you just carry on working away across that line and you will come to M58. Really nice one, this. Lots of detail in those spiral arms. It makes a great target for photography. Through the eyepiece, okay, you might be able to start seeing a little bit of that spiral structure if you really work your eye around it. But a great example of an almost face-on spiral. Now, the next thing we're going to do, okay, gets a little bit more complicated here. To find the Messier objects in this next bit, we're going to do a loop. We're going to draw a circle on the sky, and with M58, we're then going to join this loop, and we're going to work our way clockwise around it. So from M58, we then go to M89, and then up to M90, 91, 88, and then work our way down the other side. And we end up with M87. So let's have a quick look around this circle as we go clockwise around it. So M89, big, round, elliptical galaxy, very bright central core to this one, almost star-like through a small telescope at low power. With a big telescope at high power, you might be able to detect that that little sliver of a galaxy above it there, sort of almost an edge-on spiral. And that's the thing with a big telescope. Look at these, you might be able to detect dozens of faint galaxies just lurking in the background, because there are lots and lots there. The Messier catalogue is only picking up the brightest ones. Messier 90 is the next one. Now this is a nice sort of obliquely angled spiral galaxy. The angle is not unlike the Andromeda galaxy really, but this is quite a dusty spiral. In this picture you can see that those dusty lanes in the spiral arms. So that's an interesting target, that one. You'd probably spend a whole talk looking at these individually. There's a lot going on in them. M91 is the next one. A barred spiral, this one. You can see that nice sort of yellowish bar across the center. And then the spiral arms, they're more bluish with the new stars in them that are coming out from it. So a really nice example there of a barred spiral. Messier 88 is the next one. Again, great target for photography, this. Lots of sort of dusty lanes in those spiral arms. Quite a few spiral arms to this one, so there's a lot of detail there to be captured. Nice target. Magnitude 10.4, so well within range if you want to observe it visually. That's another nice target. M84, and we're back to these elliptical galaxies again. It's just sort of a fuzzy blob that so with ill-defined edges. But it does have this dusty lane that runs across the center of it. And this sort of has every indication of being interacting galaxies. So maybe the elliptical has recently, in cosmic terms, swallowed a spiral galaxy. And it's in the process of sort of dissolving those dusty spiral arms into the bigger elliptical galaxy. So yeah, that's an interesting one there. An elliptical, we think, with these dusty sort of mixed up lanes running across it. So yeah, another interesting target there. Then we come to M86, another one of these elliptical galaxies. So you can't see any spiral arms in this, but there is a hint of some dusty shells around this one. I think in long exposure photographs, there is some detail that you can see in the outskirts of this galaxy. So an interesting one there, maybe some long exposure astrophotography. M84 and M86 make this nice pair here, and these are sort of a part of what is called Markarian's chain, after Benjamin Markarian, the Armenian astrophysicist that first sort of really studied this and named it. So here we are in the thick of the Virgo cluster. We're very near to the center of it. So with a big telescope, you can see dozens of galaxies here. Professional telescope, long exposures, yeah, there are hundreds of galaxies there in total. So an incredibly crowded galaxy field. Nice picture here of Markarian's chain. And once you've found the Messier objects, those two on the right-hand side, you can use that as a pointer. So if you sort of aim your telescope along that line between the two brighter galaxies, you can then start to pick out some of these others in the chain. And next to it, we've got this rather strange interacting pair, ARP-120, sometimes called the eyes, because they can appear like a pair of eyes staring back through the eyepiece at you. About the same brightness, the same orientation. So they're an interesting pair of galaxies. They are an interesting, an interacting pair, which is why they appear in Arc of Unusual Galaxies. You can see from the shape of that bottom galaxy there, it's been twisted all out of shape. So this is a spiral galaxy, and I think that the gravitational effect of the other galaxy there has warped it and twisted it and pulled those spiral arms out of shape, which gives us this really unusual formation. So, okay, so this is the central part of the Virgo cluster, and a little box there at the central bit is actually the very center of the Virgo cluster, M87. Messier 87 is an incredibly huge galaxy. It could be up to 1 trillion stars in there, somewhere between 500 billion and 1 trillion stars. It is the biggest galaxy in the Virgo cluster, and it is, as near as damn it, in the center. Everything else seems to be gravitationally attracted to that point. So this is the very heart of it. M87, a little bit bland to look at, I suppose. It's just this big fuzzy blob. The interesting bit is that this is the very center of our local universe. So if you can spot that, that is looking right into the center of our local part of the universe. Radio astronomers find this interesting because it is a strong radio source. And this seems to be connected to this jet that's coming out of the center of it. And I know a few amateurs have been able to see this jet. You think these are sort of limited to sort of professional photographs, but no, with a big telescope and a dark sky, it is possible to see that little jet there coming out of the center of the galaxy. We think this is powered by a black hole. That's the only reasonable explanation that we have. And somehow the material falling into the black hole is powering this jet of material that sort of squirts out from the middle of the galaxy. So in terms of astrophysics, it's a very, very interesting galaxy. This dynamically, it's interesting being in the center of our local supercluster. So if we carry on up this line, we're actually moving out of the center of the galaxy now, but there's still lots of bright targets around. 99 and 98 are the next two Messier galaxies. 99 is a really pretty spiral. It's a multi-armed spiral, but it's got this single large arm on the one side of it, which I saw this a few years ago, and it reminded me very, very much of one of these storms that these Atlantic storms that come crashing in sort of during the winter months, and they've started to name them in recent years. I can't remember what this one was called, but the shape is almost exactly the same. And it's always interesting to me how nature reuses the same little bits of physics, the same patterns, same geometry on these things in so many different scales, whether it's a snail shell, a storm, or even a spiral galaxy. M98, again, it's a spiral galaxy, but we're seeing this at a much more oblique angle now. So through the eyepiece, this looks like a sort of a thin oval shape rather than a round object. So, yeah, pretty one to look at that. And again, for the photographers, it's a nice target to see in the detail in those spiral arms. To mop up the last few, we are now going to draw a straight line between the tail of the lion and Arcturus. Now, this is quite an easy line to draw because Arcturus is one of the brightest stars in the spring sky, the sort of bright orangey coloured star. So it's a nice, easy line to draw. And actually, the constellation of Coma just sort of creeps into this about halfway along. And the same line towards Arcturus actually cuts across Alpha Coma Berenices. So you've got a couple of stars there that you can use as a straight line to aim your telescope along. But if we go along this line and pick up the last couple of Messier objects, there's Messier 100. So again, it's another one of these face-on spirals, very, very pretty, lots of detail there. You can see the yellowish color at the center of the galaxy where the older stars are. You've got those bluish spiral arms where the dust is, where the fresh gas is, and this is where the younger stars are being created, and this gives it that slightly bluer color. And in complete contrast to that, the final one is M85, magnitude 10 elliptical galaxy. And once again, through the eyepiece, this just looks like a big fuzzy blob. Completely different type of galaxy. So by the time you worked your way through all of these, and you can do this, I could say you can get all of these Messier galaxies bagged in an hour if you want to, just using this method of following the lines between the stars. You can track them all down. And the great thing is, once you've done that, you can find them again. Practice makes perfect. And once you've found the brighter galaxies, these Messier galaxies, you can then use them as stepping stones to start finding some of the fainter ones. Okay, M85, there's another quick picture of it, and you can see that there's an NGC galaxy next to that. So again, this is one of those other objects that you can track down. Once you've found the Messier objects and you've worked out which one is which, you can then use your star charts to track down these others. So you could spend many hours in the spring sky trying to sort of track down these different galaxies. And that's that companion there. So wonderful objects. Okay, so that's the tour of what you can see with the backyard telescope. The next part of this is, okay, so what's this actually telling us? What is the structure of the Virgo cluster? So yeah, it's all very well looking through your telescope and just seeing these and ticking them off your list. But what in actual fact does this represent? So any part of astronomy, it's really difficult to get that depth perception because everything is so far away, you have no idea what the real distance is. It could be 10 light years, it could be 10 million. You don't know. So trying to work out what the shape of the Virgo cluster is, what's going on in it, is not an easy task. So if you do some searching online for scientific articles, you will find papers like this one here that start to work out what's going on and how the galaxy is structured. So there are lots of different measurements that people have to make, lots of debate about what's going where, in which direction, interacting with what. Not a very clear or easy task at all. Lots of maths involved in it. But by the time we worked it all out, what we think is going on is that there are several different groups of galaxies here. Now, it's in very small letters on this slide, but near the top in the sort of the oddly shaped box labeled A, you can see 87 in very small numbers. And the little circle below that is Messier 87, that giant elliptical galaxy that I was talking about a few minutes ago. That is the center of the Virgo cluster. And this A cluster here, we think, is actually the very heart of the Virgo cluster. This was, if you like, the original cluster. And the other parts of it are actually gravitationally being attracted to it and merging together. So if you imagine M87 as something, the really big, heavy gravitational lump at the center, and that A grouping as being the original part of it, we've then got cluster B, which is the next big sort of lump of galaxies, and this is falling into Virgo from behind. So it's actually heading in our direction. And this is sort of falling in towards that main A cluster at about 760 kilometers per second. So that's pretty fast going, really. There are smaller groupings which are called clouds, and we've got a southern cloud, cloud S, which is falling into Virgo from our direction. So sort of heading away from us into the Virgo cluster. And that's pretty much complete now. It's about the same distance as cluster A, so it might overshoot and then sort of bounce back gravitationally, but it's about the same distance, which is 55 million light years away from us. Cloud N, which is over on the right-hand side, is actually falling into Virgo from behind. Again, this is sort of heading in our direction. But we think that that's almost complete now, that assimilation. That is also at about the same distance as the main part of the cluster. So about 55 million light years away. Messier 49, which was one of the first galaxies we looked at, it's actually the brightest one of the Messier galaxies you can see. The brightest one there, it could be a member of the southern cloud, or it could be a member of Cluster B. We don't know for sure. The jury is still out. Like I say, this isn't an easy thing to determine. And there are three other groupings at least there. There's an east cloud, west cloud, and a middle cloud. And these are the same distance as B and moving alongside B. So dynamically, there's a lot going on here. We think that clusters of galaxies originally formed out of the Big Bang, but as time has gone on, billions of years have passed, gravity tries to pull things together. So what's happening is big, sort of really big gravitational centers like M87, they're attracting these other galaxies to them. So gradually, all of these galaxy clusters are starting to merge together. Now there's also, if we look a little bit wider than that, so we're now moving out from the cluster itself to the supercluster. There is the Virgo 2 group. Now this group here starts with Messier 61, which was sort of at the bottom of the bowl of Virgo, and it sort of stretches southwards. And we've got all of these NGC groups of galaxies, and these stretch for tens of millions of light years away from the center of the Virgo cluster. And drawing that on a star map, this is the strip of sky, and you can see how much sky the Virgo 2 cluster actually covers. Again, with a big telescope, if you're inclined, you can actually trace these. You can follow that line of NGC objects down in there, and you can tick that off your list. So that's the Virgo 2 cluster. And there is a Virgo 3 cluster as well. And this one stretches eastwards away from the central part of the Virgo cluster. Again, this is sort of an extended part of the supercluster. So if we draw this on the star map, here we are, we're looking out in this direction away from the bowl of Virgo. So again, NGC objects there. Some of them are quite bright, so you can track those down if you want. This is where you're actually starting to trace the shape of our supercluster. There's a lot to it. So, and there are different ways to map this out. There are quite a few of them online if you want to have a look. So we are at the center of this sort of cylinder here. The main part of the Virgo cluster is on the right, but we've got the Leo 1 grouping, the Ursa Major groups, the Virgo 3 groups. All of these are connected gravitationally to that Virgo cluster. So all of these groups here make up what we call the Virgo supercluster. There's a different representation of that. And like I say, there are quite a few of these you can look up if you're really interested in this. Okay, so that's our local supercluster. For the more adventurous among you, you can actually look a bit further than that if you want, because like I say, in the springtime, we're looking out at the top of our own galaxy into really deep space. So this does offer us the opportunity to look into much deeper space if we want. And the next biggest cluster of galaxies is right there in that same part of the sky. Just a little bit above Virgo and a little bit to the left of Leo, we have the Coma Galaxy Cluster, or Abell 1656. So it's actually very similar to the Virgo cluster of galaxies. In terms of size, it's the number of galaxies, it's actually not a bad representation of the Virgo cluster. They are quite similar. But this is about 6 times further away. You're now looking at a cluster of galaxies that is about 300 million light years away. Now, right at the center of this, there are 2 big elliptical galaxies. As is often the case, you have big elliptical galaxies at the center of the cluster. And one of these you can see quite easily with the backyard telescope. This picture here, they look about equal brightness, but actually the one on the right is brighter than the other, and it does stand out much better in the eyepiece. It's NGC 4889. That is a nice target. And actually, I do wonder why it didn't quite make it into the Messier catalogue. I think it's certainly bright enough to have been picked up by Charles Messier or McCain or one of the people that were doing this sort of survey work at that time. Okay, so this gives you some idea of the direction And when you look at the Coma Cluster, you're looking past Virgo just to one side of it. That's the direction that you're looking in. So yeah, wow, great. Two for the price of one, really, in that part of the sky, our local supercluster and one that's a lot further away. So you're spoiled for choice with galaxies there. One final object before I wrap this up. For the people who really want to look deep into space, there is one final treasure within Virgo that is within range of backyard telescopes, and that is the Quasar 3C273. Challenging object, certainly. You're not going to see a lot of detail in this, not at all. It's quite faint and star-like. You're looking really just a faint blue star, but it is visible. I've certainly seen this. I've searched for it and tracked it down before. Again, online, if you are really keen to do this, there are quite a few different finder charts. If you draw a line between Messier 61 and Gamma, which is at the bottom of the bowl of Virgo there, actually it's kind of along that line. So again, you can use sort of stars and these other objects as pointers. They will help you to track it down. So there it is. It's sort of just over halfway along that line there. Another finder chart for it. Like I say, what you were looking for with this is really just a faint blue star. But with high magnification, it is possible. I've never seen it myself, but I'm informed that it is possible visually to see that jet of material there. That's a little wiggly worm that's coming out of the left-hand side of it. That isn't just a trick of the light. That is actually a jet of material coming out of the quasar. And again, just like Messier 87, where we saw that jet coming out of the center of the galaxy, we think this is one of those effects of a massive black hole. We think it's the black hole that is powering the quasar. And the activity of that black hole is causing this material to squirt out of the center, and it makes that jet, which is just visible at high power in amateur telescopes, apparently. So if anybody manages to see that, please let us know. I'd love to find out if you can actually see it, because I think that is an incredibly difficult target to try and track down. But certainly I think there are some American observers that say that they have been able to see it. So there's a really challenging target for you if you want to take that up. In terms of distance, yeah, this really is deep space. This is something like 2 billion light years away if you take the redshift measurements. Okay, illustration here of what we think is going on in the center. It's that black hole that's powering it. Stuff falls into the black hole. Somehow this triggers an outflow of material very, very rapidly along the magnetic field lines, which create these jets. How do we know that it's not a star? How do we know it's something different? Well, we do that through spectroscopy, and this is the spectrum of 3C273. And this is also what you use to determine the distance, because these spectral lines here, where you can see the sort of the peaks of this graph, where it's got hydrogen alpha and hydrogen beta, hydrogen gamma, and so on, these peaks here are shifted very much to longer wavelengths than they would be ordinarily in a star or a galaxy. So we put that down to the expansion of the universe, and that's how we work out the distance. And this is why we are informed that this quasar is over 2 billion light years away. But there is still the odd dissenting voice, and as is now traditional, I will mention Halton Arp, one of my favorite astronomers here. Arp had a very different viewpoint on this. He thought it was too much of a coincidence. The 3C273 actually appears sort of so close to the Virgo cluster. And as he described it, it said it was an especially embarrassing skeleton in the intervening galaxy closet. The brightest apparent magnitude quasar in the sky, the famous 3C273 at 0.158 redshift. Evidence since the 1960s places this brightest of quasars in the center of the local supercluster, even though its redshift is 52 times greater. This usually triggers some debate, this. It is a heck of a coincidence, isn't it? The brightest quasar, not just the brightest, but by a long way, the very brightest quasar in the night sky is actually very close to the center of our local cluster of galaxies. Heck of a coincidence. If you trust the redshift, it is pure coincidence. It is much, much further away. But it's always interesting to debate that one. Placement, it would be just down the bottom of that south cloud there. So that's where it is in relation to the central part of the Virgo cluster. But an interesting observation that anyway. So was ARP right? Do we trust the redshift measurements or not? So anyway, there's a quick tour of our local universe. It's amazing what you can see at this time of year. If you like galaxies, absolutely fantastic. You can have a real field day out there on a clear night, clear moonless night. So what I would say is go out and enjoy it. Lots of galaxies there to explore. A bit of everything there. Every type of galaxy, there is a good example in the Virgo cluster. So it's a great way to spend a clear night during the spring, I think. So that's enough from me. I think time-wise, it's about 5 to 9. So I think that's a good point to stop and just say, any questions from anybody?
I really enjoyed that, and if you unshare your screen, then people will see us. I've done myself a little cheat card with Leo on one side, looking quite naked actually. Just literally, that's it. That is the triplet. The PTO for Virgo, and woohoo! Lots of exciting things to see. So I think I'll do that. But I didn't realise that that quasars could be seen and spotted with kind of backyard stuff. So that's really interesting. So I've learned something there. Thank you for that.
Yeah, you can't really see any detail in them. They're star-like, basically. Yeah. But you can track them down. There's about a dozen of them, I think, that are bright enough to be seen in a big backyard telescope. So you've got a 10 or a 12-inch telescope, you can track them down, but don't expect to see any detail in them. There's only 3C273 where it's got that little jet that possibly you might just be able to see that jet. Everything else is star-like.
Which would be so cool. I mean, I was talking to Chris Duffy a while ago about his accidental imaging of quasar PG 1718 plus 481. And I know that because we're talking about that in the Astro Ventures chat. And he's just shown me that picture. He was imaging a part of the sky for something else and saw the quasar. And he managed to, through a telescope not dissimilar to the one we have at the observatory, image something halfway across the universe, like 7 billion light years away. It's nuts.
Well done for knowing that he'd actually accidentally imaged that object.
Yeah.
But how do you even know? Oh, look, I've accidentally imaged a quasar. Wow.
Yeah.
That's dedication. Super.
Yeah. I mean, I don't know how if you talk to Chris in any detail at all, he really goes for it when he's imaging, and he's normally got quite a comprehensive knowledge about what should be in the image. So things that surprise him are normally very quickly investigated. Like, by the way, Cass the Nova in Cass, which is an interesting thing that's happened. The Cassiopeia Nova. I don't suppose you've managed to see that yourself, have you, in the last couple of weeks?
I haven't, no. Novae aren't one of my special interests, I have to say, and Cassiopeia is a bit low down here, so
it is.
From my back garden, actually, the view towards the south and Virgo is much better. So I haven't looked at the Nova myself yet, but I might later. That's a good prompt. Thanks, Roy. I might pop out and try and track it down.
It won't last very long, will it? That's the thing.
No, they tend not to. No.
Well, we do have a couple of questions. One was with the filter that you recommended. Was there a specific make or type of the UHC filter?
Mine is an astronomic with a K at the end.
Astronomic.
UHC, yeah, astronomic UHC filter.
UHC filter. Okay.
That works really well, but you can get the ones that are called light pollution filters, astronomic, Lumicon, another big name. I think if you go for a name brand like that, you can't go far wrong.
Cool. We have
it makes a hell of a difference, Roy. I have to say, getting a filter is one of the best things I've ever done. Top tip. It makes so much difference to being able to see these, because it really does wipe out a lot of that light pollution. It cuts out a little bit of the starlight as well, but it cuts out a lot more of the light pollution, and it makes these things visible, where going back a few years before the filter, I would never have been able to see some of these galaxies because the light pollution would just kill them stone dead.
Okay, we've got the same telescope, so maybe I'll borrow it from you. But actually, they're not cheap, but they're not expensive, are they? So maybe I'll just buy one. Do you have the 2-inch or the 1.25?
I've got a 2-inch one, because with the 12-inch scope, I tend to use 2-inch eyepieces almost exclusively these days. I do have a cheaper UHC filter, just a 1.25 inch. I don't use that very often. That's just an unbranded one. Doesn't work as well, but I don't use that for serious sort of deep sky observing, to be honest. So I'm not entirely sure how well it works.
No, it's understandable. I mean, the 12-inch Dobsonian that you and I both have, they're absolute huge light buckets, so they're really good. I had a question, but it's gone. It was one that I wanted to ask you. No, I've got it now. When you're trying to view these galaxies, I know with Andromeda, we tend to, because it's quite close and quite big, the recommendation is always to use quite a wide field of view eyepiece, something like a 40mm or a 30 or 40mm eyepiece for our scopes, for example. But when we're trying to kind of aim in on these much more distant galaxies, what would you recommend for your focal length of your eyepiece for that?
I tend to use 26mm Plossl. I've got a Celestron 26mm eyepiece, and that gives a nice wide field of view. For like the Leo triplet, you can get all of the galaxies just in the field of view. I quite often use a 13mm Vixen eyepiece as well, so that's twice the magnification. What it does is it darkens the sky background. So sometimes if you think, yeah, there's a galaxy there, I can just see it. Actually, a bit more magnification darkens the background and makes it stand out more. Your initial thought might be, yeah, as you increase the magnification, you might think, well, actually, you spread the light out and it sort of makes it disappear a little bit. But actually, the reverse is true. Sometimes the higher magnification darkens the background and brings it out a little bit. It's worth experimenting, just see what works for you. But my standard eyepiece is that 26mm Plossl.
Cool.
Nice wide field of view. And certainly for the Messier galaxies, it's a nice size. They tend to be, you can see that sort of smudge in the eyepiece quite easily. So it works well for those.
Yeah, and I think that's an important thing that a lot of people need to appreciate when they're looking through their telescopes at this kind of thing, is that the vast majority of these galaxies are just going to look like little smudges of light in the eyepiece. So you're not going to expect like a Hubble kind of rotate. I loved your rotating galaxy GIF. I really liked that, actually. But it's really important to set people's expectations. These are wonderful things to look at, but then you're not going to get like Hubble view through your eyepiece.
Absolutely, and that's one of the reasons why I mentioned the book by Jack Newton, this Cambridge Deep Sky album. The pictures in there are a good representation of what you will see through the eyepiece. Yeah, so fuzzy streaks and fuzzy blobs. So I think you have to be a bit of a nerd really to love galaxies the way that I do, because you don't see that. You don't see that amount of detail that you can in something like the Orion Nebula, or some of the big globular clusters. You're looking at fuzzy blobs, and for me, it's more about what they represent.
Yes.
To know that you're looking at something so far away in space.
Yes.
So many billions of stars. That's the mind-blowing thing that really captures me.
And we now know. So this leads me on to a question we've had from the audience. And Joanna, I will get on to your question, so just be patient and bear with me. By the way, a couple of people point out that book is available on various websites for about £7. So that's been really useful. People joining and helping there. That's kind of got me thinking about planets, because obviously when you're looking at these galaxies, when you're talking about what they represent, we now know with quite a strong degree of certainty as scientists, as astronomers, that every star has planets around it. Obviously, not every star is going to be a star that is capable of producing the kind of heat and light around the kinds of planets that will support life. But given how many stars are, like main sequence, G-class, is that right? Yellow dwarfs like our sun and similar, and how many of those have rocky planets in the habitable zone, the Goldilocks zone, we call it the Goldilocks zone. Maybe tell us a bit about that. We know that there's bound to be people looking back at us. People, I don't know what, but there's got to be people out there, aliens looking back, I think. So there was a question from somebody, and somebody had asked, with Andromeda, when you were talking about Andromeda, Dave, right at the beginning of the talk, someone said, obviously, we've seen exoplanets within our galaxy, around planets. We've directly and indirectly observed them. And I happened to be reading something somewhere that said that the furthest planets we've directly observed within our own galaxy are only a few thousand or a couple of tens of thousands of light years away, which is still quite small in terms of distance within our own overall galaxy. And the question was, do we know of any visual evidence of planets inside Andromeda? I mean, I think there's been some indirect detections, but is there any direct visual evidence of planets in Andromeda?
I don't think there is, not yet. You have to think about how they work out that there are planets around another star. And there are two ways to do it. One of them is by looking for the transits. So you look at the light curve, and if you get sort of a sudden dip in the light curve from a star, you know that something has passed in front of the star. So if this happens on a regular basis, you can infer from that it's a planet going around the star and it's dimming the light. What this means is the star has to be close enough for you to be able to get a good, reliable light curve from it. And the trouble is with other galaxies, even Andromeda, because they're so far away from us, the light from all the stars mushes together. They're too close together. You can't separate out individual stars to look at. So for trying to find a planet transiting in front of an individual star becomes an incredibly difficult task. It's hard enough within our own galaxy. And the other method of looking for planets is for that wobble in a star's orbit. So yeah, it's the Doppler shift in the spectrum. So as a planet goes around the star and it tugs the star a little bit, you see the star moving backwards and forwards a little bit, and you can see that movement in the spectrum. Again, you're relying on being able to single out that star and look at its spectrum individually. And in other galaxies, the light is just so squashed together of all those stars, you can't separate them out. You might stand a chance with Andromeda, I suppose, some of the bigger, brighter stars on the edges. After all, it was Hubble looking at the Cepheid variable stars that enabled him to work out the distance. So I think for some of the bigger and brighter stars in Andromeda, it might be possible, but I don't think they've done it yet.
I googled that, obviously, when you're doing the talk, I'm kind of looking and googling, and I think there was potentially a candidate where a micro lensing, because obviously galaxies, when they pass in front of each other, or clusters of galaxies, when they pass in front of each other, can warp space and either allow the galaxies further behind to be lensed around that warped one and be seen. But there are things that happen within galaxies called micro-lensing events. And something happened in Andromeda. I think they recorded it in I've lost the page now. I had it a minute ago. In 1999. And basically it was consistent with two stars going in front of each other, one obviously very massive. And there is speculation that the way that the lensing occurred implied that one of the stars must have had a very large gas giant planet associated with it. And so if that, obviously it was a one-off event, that was it. We can't go back and look at it, but there's potential that things like that might be happening in Andromeda, or will be happening. We can spot them.
It is. Micro-lensing is an interesting technique, and you can use it to try and spot planets, but these are one-off events really, where something just happens to cross in front of the other. So there's a large element of luck involved in that. But yeah, that does that rings half a bell with me, actually, Roy. I do think that sounds.
Yeah.
Yeah,
that we would have read about at the time.
Read about that a few years ago. Yes, indeed.
Yeah. Now the last couple of questions we've had about binocular observing, and Joanna Woodward has said. So the one question I can answer straight away, which is Doug has said, and Joanna have both said, how do we observe with binoculars? You know, are there filters, light pollution filters for binoculars, and so on? Someone else said, are there any good books? I don't know of any light pollution filters, but Dave is a much better, more accomplished astronomer than I am, so I'll ask Dave. But the person who I think definitely know this is the author Steve Tonkin, who has written 2 or 3 really good books, actually more than 2 or 3, on binocular astronomy. I've got one somewhere. I don't know where it is. Normally all my astronomy books are quite to hand, but I'll have to go and have a look at that. But if you want, Doug, if you want a good book on binocular astronomy, then Steve Tonkin's book. And obviously, we all love the book Turn Left at Orion, which has lots of sketches, if you like, of what you would see through small telescopes and so on. And that gives you a much more realistic idea of what you'll see as well. But binoculars for light pollution filters, have we heard of that, Dave?
What? No, I think you're into the realms of building your own here.
Yeah.
I don't Astronomy, see why. Yeah. Filters. You could get a couple of those sort of unbranded sort of light pollution filters, the 1 1/4 inch ones maybe, and experiment with them. Just see if you can put them somewhere in the eyepiece of the eyepiece cup of the binoculars and use them that way. There must be a way to do it.
There must be. I think Joanna needs to channel her inner Blue Peter presenter and get some old yogurt pots and some sticky back sellotape plastic and cardboard. Buy 1 or 2 of these astronomic filters, sell a kidney, to be able to do that, and cobble something together yourself. But what I would say is that the go-to astronomy expert for binoculars is Steve Tonkin. And he does a little monthly binocular sky guide called Binocular Sky, actually. And I'm going to copy the link to that in the chat. And Dave and I can talk about astronomy and binoculars to a reasonable degree. Steve he's a legend. Let's see, I wonder if we can get Steve to do a talk for us online. Lots of thank yous. Oh, here we go. There's Binocular Sky. Right, here's the link to Binocular Sky. Are you still there, Dave?
Yes, I'm still here.
Lots
I think
of
the issue with binoculars. I think the issue with binoculars for observing galaxies is the size of the galaxies is quite small. They lend themselves more to the higher magnification that you get from a telescope. At 10 times, 15 times, they're going to be very, very small in the eyepiece. So I think it's going to limit you to the brighter galaxies like M61 and M82. You can certainly view those with binoculars, but it needs a steady hand or sort of a tripod to mount them, and you have to know exactly where you're looking to pick them. Binoculars are certainly the best way to view the Andromeda Galaxy, because it won't fit in the telescope eyepiece unless you have a very wide field telescope. So binoculars are great for Andromeda.
That is something we can see in urban environments as well, isn't it? I mean, I remember doing an astronomy and an adult education astronomy thing in Newcastle at the college, and we had 8 or 10-inch telescopes in the car park under the lights, and we were able to see quite easily in that environment and the Orion Nebula and the Andromeda Galaxy and a couple of the brighter clusters. So it's we should go for it. Lots of thank yous. I've put a couple of the Binocular Sky links in the chat for people. Doug, all I can say, just answering your question here, is you've just got to practice and practice and practice. And, when we're all allowed to socialize again, when we're all allowed to meet each other under dark skies again, perhaps get yourself up to Northumberland. And there's several really great observatories up here. We're obviously, we do the Battlesteads. But also there's also, wherever you are in the world, there will be a local astronomical society to you. So, and it's always worthwhile seeking those out online because they're normally very friendly and welcoming, and you can try out people's equipment and binoculars and so on before you buy. So that's good. Postscripts, Twitter. Thank you so much, Dave. Another one. Kyle, I'm a complete novice. I've just started to locate the various constellations at the start of this year. Do you have any of the sources I can follow up and read on? Dave, complete novice. They can just find a couple of constellations. What do you think they should do next?
Well, I can tell you how I started. I started buying an astronomy magazine every month, and right in the center of that, you've got that star map, usually sort of in the center spread, that just shows you what the night sky is like when it gets dark. And that's how I started to learn the constellations. And looking to see what was up that month, it would tell you. So I started with the American Astronomy magazine. I tell you, it was March 1983. That was the first issue I ever bought, showing my age now. So this was long before Astronomy Now and BBC Sky at Night magazine came along. It was that or Sky and Telescope, and you were lucky if any sort of news agent in this country would stock them. But it was eye-opening for me. That was really the start of my proper astronomy journey. Yeah, there are books you can buy, but I think getting that monthly magazine and just gave you different highlights and things to look for every month. That was great. It worked for me, and I would certainly recommend that. So gives you a little point of interest and something to look forward to, and something new to explore every month when the new issue comes out.
I would 100% agree with that. And because you're looking at that particular month's astronomy guide, you're not going to be distracted by trying to find things that are not bright enough or too close to the horizon, or actually just simply not visible. Trying to find Orion in the summer is dark, for example. And if people want direct recommendations, there are the two that I like at the minute. I like Sky at Night magazine, BBC Sky at Night magazine. But I really like All About Space. I must say, All About Space magazine lately, of the last few months, their issues, a lot of the articles, fantastic. So get stuck in that. Is the talk being recorded? Will it be on YouTube? Yes, it will, Gerard. And not only that, but you can look back through our channel at other talks that have been that we've done. And Dave did a really fantastic talk, which is in our Northumberland Dark Sky Festival playlist. Dave did a talk about the Newell telescope, the Gateshead telescope from Gateshead Galaxies. So if you like Dave and his presentation style, then that's the first one of those you should look at. And what can I say? Please like this video, give us that thumbs up, subscribe to this channel, because we are planning to do more and more events like this. We've got a stargazing festival coming up in October and November, and we've got the next Northumberland Dark Sky Festival in February 2022. And although we desperately and dearly hope that we're going to be able to see you all under our dark skies, what we have found out is that we can reach so many more people online. So we will be doing a blend of real life and online. So do like and subscribe. Set notifications if you want to get notified straight through YouTube rather than Eventbrite as well. Oh, by the way, Kyle, get apps on your phone. So there's one called Stellarium, which is free on your computer, and then you've got apps like this one, Sky Map. This is my little Android phone, and what is good about apps like this is you can point them anywhere in the sky, and it shows you what is in the sky where you're pointing it. And this is an Android one. Dave, do you have Android or iPhone? Do you know?
This is Android. Oh. I've got the same app. I use Sky Map too. It's very, very good.
Yeah, and a couple of things I absolutely love about it is you've got the night mode, so you can change it into everything being red. So all you can see there is me. But at night, that's still quite bright. Having red is useful. But also there's a search function as well. So you can, if you're struggling to find the Andromeda Galaxy, you can just type it in there and you get a little circle comes up. I'll show you, folks. That actually is one of my favorite things to do when we're at the observatory. And all you've got to do is point your phone towards that arrow, and then the circle at one point will get nice and big, and you'll know that your phone is pointing at that object. So do go for that. Dave, just to finish off quickly, because I said there about red lights and night sky, dark adapted vision. Can you talk a little bit about that? So that's a top tip here, is even looking through telescopes, why and how do we go, do we get our night vision ready to spot these galaxies? And could you tell us a little bit about the skill called averted viewing that would help us to do that, astronomers?
Okay, well, our eyes have adapted in a particular way to spot motion in the dark. The central part of our vision, which is the color vision part of the eye, doesn't work very well when it gets dark. So when it gets dark and you're outside, you tend to lose your color vision. You see everything sort of black and white. And this is because it's the periphery of the eye that's working rather than the central part that sees in color. That periphery is very, very good at detecting movement. So when you're looking through the eyepiece at something like a faint object, the best thing you can do is not look at it directly. So not just sort of point your eyeball straight at the center of the object, because the light there is actually falling on that color part of your eye, right at the center. That doesn't work so well. The best thing to do is actually work your eye around the outside of it. Just sort of go in a big loop around, just scan your eye around the field, and actually your peripheral vision will then start to pick out the shape and the detail in the object. So this is the idea of averted vision. Now you can improve your averted vision by keeping away from bright lights for a good 10 minutes, I would say, to let it start kicking in. I mean, after a few seconds, your eyes will start to dark adapt and that peripheral vision will get better. But to get properly dark adapted, you probably need 10 or 15 minutes of being in real darkness. That lets a substance called visual purple build up naturally in the eye, and this is a chemical that the eye uses to help your peripheral vision see better in the dark. That visual purple substance is destroyed by bright white light. So this is why when you go from a brightly lit room into a dark room, you're kind of blinded for a few seconds. You can't see anything because the white light destroys that visual purple. And it takes a few seconds for it to start building up again in your eyeball. So if you let your eyes dark adapt for a good 10 minutes, you should then be in a good position to actually start looking for some of these fainter things through the telescope. If you can let it dark adapt for half an hour or more, that's even better. You know, the longer, the better. But you get that sort of law of diminishing returns after a while, you know, between half an hour and an hour, your vision isn't going to get, you know, that much better in the dark. But a good 10 minutes, keep away from white lights. Red light is fine. The energy of red light isn't enough to destroy the visual purple. So if you use sort of a red LED light, that's absolutely fine. And at a star party, you find everybody's wandering around with red lights. And that's why it doesn't ruin your night vision. So red lights are the way to go.
Great, that's great. That's absolutely. And you touched upon a couple of things there that we also talked about, you know, in our festival. And we always talk about this, which is the dark adaptation, which is being outside for 10 minutes or so. And I learned something during the festival, actually. That it's called the rod cone break. So the cone cells, the color eye cells that you talk about, the rod cells are the dark adapted kind of black and white cells. And there's a point where the cone cells stop becoming efficient and the rod cells become more sensitive, more efficient. And that is at 10 minutes. So 10 minutes is a cracking piece of advice. Stay out for at least 10 minutes. And the point of diminishing returns comes at for different people between 20 and 30 minutes, depending on how old you are. But you and me, I think, Dave, we probably stay out for 30 minutes. We're a bit older now, aren't we? I remember when we first worked, I met you for the first time, we were working up at Keeler Observatory, and I must say it's always a joy to watch you present, especially with children involved and so on. And I remember being outside once or twice with some of the younger volunteers and some of the people that were helping us, trying to see who could spot the first star in the summertime when the first star would come out. And all the younger astronomers and all the younger helpers would see the stars minutes before I could. There it is. They'd be like, where? Well, where? There, yep. Just there.
Yep.
And he'd be like, where? To 3 or 4 minutes, that would be what you'd be doing. There it is. Where? There it is. Where? But that's summer observing for you. So, yes, and I like the idea about looking around. And that's, people may already have done this averted viewing, looking around at something rather than
that's right, yeah.
People may have already done it without realizing. When you, in the winter time, when you're looking at Orion, and off to the right of Orion, you can, or his left, our right, you can see a little cluster of stars known as the Seven Sisters or the Pleiades. That's a classic way of demonstrating averted viewing to people, because if you look at it directly, you'd be lucky if you can see the 5 or 6 really, really bright stars that are there. But as you look slightly away from it, as you look away, it pops out at you. And you think, oh, what's that? And you look back and it goes. But what you need to do is look slightly to the side of it. And then what I find, for me, what works really well is if you've got there's the object, it's just slowly looking around the object. And that slow movement gives me that kind of dark adaptation plus the movement aspect. You're talking about, you mentioned that your rod cells are adapted so that you can see movement better. So don't just look away from the object, but look slowly around it too. There are so many people that, don't get that. And obviously if a car comes around the corner, someone here has said, if you have dark adapted eyes and you see a car coming around the corner, close one eye until it passes. And the one you want to close is your good eye, you're looking at. We'll close both.
Yeah, top tip. Yeah, I like that.
Top tip.
Yes, indeed.
Yeah, I think that's it. We've got lots of thank yous, still loads of thank yous. People are going to come and see us in Northumberland.
Fantastic.
The number of viewers concurrent is diminished now, although we have had 422 viewers during this live stream.
Wow.
And I think we would like to say thank you. That is a wow, isn't it? That's great. Thank you so much for joining us, everybody. And I'm going to say it again.
Thank you all.
We're YouTubers now, Dave, so we have to say, please like our channel, and like this video and subscribe. I probably did that wrong. Please like and subscribe. Is that what you're saying? I think that's what we're saying. And join us next time. I do think that we are planning to do some more live streams as well. I know Dave has got a number of presentations up his sleeve. I know Larry wants to do some. I know Chris is talking about doing a few little brief 10-minute snippets on astrophotography. And we might be able to persuade Martin to do some for us as well. So we do have plans kind of over the spring and the summer to do more and more live stream chats. So do subscribe if you're interested in that. It's a much better way of getting onto the videos than it is to go through Eventbrite. But we will keep you emailed through Eventbrite as well. I think that's probably it, Dave. I think we need to say our goodbyes.
Okay, so thank you, everybody. Like and subscribe.
Like and subscribe. Yeah, and I'm going to do that thing where I awkwardly end the live stream, but then look, have I ended it? Have I ended it? So I don't know where, Thanks, everybody, for joining, and